Alright guys, so by now you probably figured out that Mrs. Brown is not in class today, so you are going to follow along with some video notes. I expect for you to be on your very best behavior. I do not want to have any reports about people being disruptive or up out of their chairs or any of the things that we know are that we shouldn't be doing when there's a substitute in the room. So I would appreciate it if you guys would be on your very best behavior. You're going to need your Think Up book today, so if you have not grabbed that, please go grab that very quickly. Turn in your homework from yesterday, which was the frames that we were using for unit rate and measurement conversion, so go ahead and turn those into the box, and then we will get started on the rest of the stuff for today, okay? All right, guys, so again, we are looking at page 70 in your Think Up book. You can go ahead and tear this out because when we finish this today, you are going to add it to your notes and then update your divider. When making conversions between measurement systems, a conversion factor is used that compares one unit of measure in one system to an equivalent value of another measure in another system. That sounds an awful like unit rates that we've been talking about. For example, when converting inches to centimeters, the conversion factor 1 inch is equal to 2.54 centimeters, and that's going to be used. It is important to note, with the exception of the conversion factor 1 inch is equal to 2.54 centimeters, all other factors between systems are approximations and answers will be estimates, which means that we are probably going to have to round a little bit within these measurement systems. So, guys, the rest of the things in the box are going to be notes for you to refer back to, okay? What I would like for you to do, instead of listening to me read all of those things to you, is to go ahead, pause the video right now, read through everything in the box, okay? Make notes of any questions that you may have out to the side so that I can address those when I get back to class, okay? So go ahead and pause the video now. Read everything that's in that box, and then come back to the video once you've done that. Please stop and do that. Make the best of your learning today. Don't just keep scrolling through. Thank you. All right, guys, so hopefully you paused the video and you read through the information that was in the notes page on this box. If you notice now, I'm at the bottom of page 70, and I'm going to use a little bit of scratch paper to do some of this work. So if you run out of room and you want to grab scratch paper, that's completely fine. Just make sure you include it in with your notes. The other thing that I have grabbed that you have a copy of in your notebook is the 7th grade mathematics chart. You may need that for some of the conversions that we are going to do, mostly hanging out here within length, the customary and the metric. So go ahead and grab that. Remember that your ruler is not going to be accurate, so don't try to do anything with your ruler with the one in your notebook, but everything on your reference materials as far as the units, that will be just fine to use today, okay? All right, so let's look at page 70. Okay, number 1 says that Robert runs 48 kilometers. If 1 mile is about 1.61 kilometers, how many miles did Robert run? Round your answer to the nearest tenth. Okay, so guys, when we think back to the WKU that Marlon worked with us with on, I believe it was Tuesday of this week. So remember, we're comparing two things. Now they're units of measurement, so we know that we are comparing miles, and we are comparing those miles to kilometers. Okay, so those are our two units that we're comparing. We also have a ratio that we know right now. We know that 1 mile is equivalent to 1.61 kilometers. So what I'm going to do, because I want some more space, and let me try to just kind of get this adjusted a little bit over here so you can see everything. I'm sorry. Okay, so we are comparing miles to kilometers. I'm going to go ahead and make my little ratio table. Okay, I know that 1 mile is equal to 1.61 kilometers, okay? I want to know if I run 48 kilometers, how many miles that is, okay? So how am I getting from here to here? Well, one way that we can solve that is to put 48, and we can divide it by 1 61/100. You can go ahead and set that up for me. Okay, so we can figure out what 48 divided by 1.61 is. And if we do that, we get 29 point, I'm going to go ahead and write out the three digits after my decimal. So I have 0.813. Well, it told me that I needed to round to the nearest tenth. Well, the tenth is the first place after my decimal. If I look at the number behind it, that's a 1, which means that my tenths place can stay the same. So that would be 29.8 miles. Okay, so I'm going to write that up here, 29.8 miles. So I use this unit right here in order to determine how many miles were in 48 kilometers. Okay, let's look at number 2. And again, I am going to use scratch paper, so if you want to do the same thing, that's completely fine. Just make sure you're numbering. The average weight of a 9-banded armadillo is 4.5 kilograms. What is the armadillo's average weight in pounds? And it tells us that 1 kilogram is approximately, that's what the two little kind of squiggly looking equal sign looks like, approximately 2.2 pounds. Okay, so we know that we are comparing kilograms to pounds. Okay, so if I wanted to go down here, I could go ahead and make my ratio table, kilograms and pounds. Okay, I also know from my problem that 1 kilogram is equal to 2.2 pounds. I want to make sure that I line up my labels correctly. 1 kilogram, 2.2 pounds. And I want to know how many pounds are in 4.5 kilograms. So this relationship is pretty easy to see. Excuse me a second, I'm going to erase that because I didn't leave myself one mushroom. So I know that 1 times 4.5 is equal to 4.5. And if I do 2 2/10 times 4.5, I would get 9.9 pounds. Okay, that was a really clean decimal that they left me with, so we can leave it just like that. 9.9 pounds. All right, let's look at number 3. Madison visits her cousin in England, and the girls purchase a 3-liter carton of milk. How many 1-cup servings of milk are in the carton? Round your answer to the nearest tenth. So this tells us that 1 cup is equal to approximately 237 thousandths liter. So let's talk about our units that we're using, and I'm going to go ahead and kind of make number 3 down here. Okay, we know that we're comparing cups to liters. Go ahead and set up my ratio table. My problem tells me that I have 1 cup, and that is equal to 0 and 237 thousandths liters. And I want to know how many how many cups are in 3 liters. Okay. How many 1-cup servings of milk are in a 3-liter carton of milk? Sorry guys, somebody came over. I might have to pause for a second. Okay, so we're trying to figure out how many cups are in 3 liters. So in order to do that, we could do 3 liters, and we could divide that by 0.237 If we do that, we're going to get a decimal, and that decimal is going to be 12.658, okay? It told us that we could round to the nearest tenth. That's one place after my decimal, okay? So I'm looking at this 6. But behind the 6, I have a 5. So that means that my 6 is going to round to a 7. So number 3 will be 12.7 cups. Okay, go ahead and tear this out. You're going to, don't worry about page 71. You can fold it in half and glue one of them. If we get to page 71 later, I'll print you guys a copy of it. Go ahead and tear this out. Put this in your notes and go ahead and add number 4 to your divider that says think up, page 70. I'm going to pause this video for a second, give you guys a chance to do that, and then I will come back on. All right, guys, I'm going to go ahead and upload this video because it gave me about a 15-minute maximum, and we're at 11 minutes. And I want to be able to explain your measurement think dots paper to you. So I'm going to go ahead and upload this video. Stay tuned for video number 2.